Hi, manager. As you well know, I was hired here at Orange Incorporated to improve basic functions in the backbone software that our employees use. Now, I was looking through some of our utility methods earlier today, and I realized that the sorting method that our employees use to sort data was actually bubble sort. And now, I just want to take a few minutes to explain in this video how we could do better than bubble sort and how using another algorithm could really save our employees a lot of time trying to sort big data sets. As you can see here, this is the basic implementation of bubble sort that we are using. It takes in an array and then uses a nested for loop, two for loops, to compare each element of the array with every other element of the array. And then it sorts accordingly. While this does sort, and it is very simple, it is not very practical in terms of speed and efficiency. Bubble sort would run in order n squared for big O notation, which is the time complexity analysis of the algorithm. And so n squared is not something that you want out of an algorithm, as it's not very efficient. And the speed of the sorting would also heavily depend on the size of the data set we're trying to use. If you had a data set of 5, then it would take 25 comparisons to sort, and it would just grow exponentially. What I thought we could use instead of bubble sort was use merge sort, as you can see right here. As you can see, merge sort is a sorting algorithm that calls itself recursively, uses low, which is the beginning point, and high, which is end point, to break down the array into the lower and upper halves. And it will continue to call this recursively until all that's left in memory is arrays of one element each. And at that point, it would start merging in sorted order. Because of how it breaks down the data set by literally splitting it in half every time, the merge sort would run in order n log n, which is infinitely better than the efficiency of n squared like bubble sort. Let me use this chart to compare the two algorithms. If we look at the best case scenario for bubble sort, it's actually better in terms of time than merge sort, because O of n would be less than n log n. However, this is a very impractical situation because the only case in which bubble sort would be O order n would be when you're trying to sort an already sorted data set. At that point, there's no point in sorting in the first place. What we have to pay attention to is actually the worst case and average case. In the worst case scenario, bubble sort would take order n squared when it's trying to sort the reverse sorted array. So if you're trying to sort in increasing order, the data set would be in decreasing order. So you have to make every comparison in order to sort. The average case would also take n squared by nature of bubble sort being a nested for loop. Merge sort, on the other hand, would be order n log n every single time, irrespective of best case, worst case, or average case. This is because of the fact that it breaks down the data set in half every single time. So what this all means in the overall scheme is that merge sort is less than bubble sort in terms of comparisons and time taken. And what this means is that when you're trying to use big data sets, merge sort would save our employees a lot of time. As you can see, the size of the input, the efficiency and speed the time taken would grow exponentially with the size of the input n. While in merge sort, it will not matter until n is so big that data does not fit into memory, which means that the data you're trying to sort would have to be gigabytes and gigabytes of memory. At that point, there would be other methods that you can use. Now, this concludes my presentation on merge sort, and I hope that I was clear in explaining how merge sort is more efficient and faster than bubble sort. And I hope that you can give me the green light to update our sorting algorithm. Thank you very much.